Hello, Assalamu alaikum. Myself Muntasir Mamun, and I will be presenting one of our research works, which is titled "Vibration Response Analysis of a Structural Metal Mild Steel Under the Effect of Crack." And my other two co-authors are Nihal Ahmed and Ashfaq Ahmed. Well, this is the presentation layout. The first there will be introduction, then objective, methodology, results and discussion, conclusion and future development, and then references. So here comes the introduction. So when a crack is present in a structure, then the probability of failure of that structure is higher. Failure occurs when the natural frequency of the periodic force and the natural frequency of the structure are in a state of superposition. To avoid this phenomenon, it is essential to calculate the natural frequency. So here comes the question: what is natural frequency? A natural frequency at which a system tends to oscillate in the absence of any driving or damping force is called natural frequency. And the characteristics manner in which the vibration occurs is called the modes of vibration, which is also important which is also important in concern of the failure of the structure. So the aim of this study is to analyze the behavior of natural frequency for different parameters such as crack position, crack depth, crack opening, and mesh sensitivity. Well, now let's talk about the methodology. So there can be various types of cantilever beam depending on the geometry of the cross section. Here in this study, an I-shaped cross section has been used for designing the cantilever beam. For I-shaped beam, the dimensions were same as the dimension of a HE 1000 into 584 steel beam. So as the flange thickness, web thickness, and depth, fillet radius, width, length are here as shown. So this is the computer aided design of the beam used in this study. So a wedge shaped crack was used to analyze the behavior of vibration under cracks. The cracks were drawn in SolidWorks 2017, and then the files were imported and used into Abacus CAE. For the examination, mild steel was used as a material because they were very commonplace in terms of usability in structural elements. So the boundary condition is used here is Ncaster, which is u1 equals to u2 equals to u3 equals to ur1 equals to ur2 equals to ur3 equals to 0. So the meshing, the area around the crack was partitioned to get more accuracy. The tip of the crack was partitioned and the wedge element was used. So from the analysis, it can be seen that the values of natural frequencies almost coincide. Without partition, the I-beam could not be analyzed using hexahedral and wedge elements. So only tetragonal and mesh elements were used while analyzing without partition. So like I said, we can see that the values of the natural frequencies almost coincide, and the result converges after 14,364 elements. So from this we have obtained the meshing criteria. So this is the I-beam after the final meshing, and here you can see like I said, the hexahedral elements in overall the beam, wedge elements in partitioned area. So the natural frequency analysis of cantilever beam is validated by the natural frequency solution of MS Mia, MS Islam, and U Ghosh. So okay, now here comes the results and discussion. Uh, the results are analyzed in terms of mesh elements and crack opening, crack depth, and crack position, which was the objective of this study. And abacus analysis results for different mesh elements are shown in this table. It is observed that the partition meshing causes greater fluctuation in natural frequency, which can be subjected to the decreased natural frequency theorem for a discontinuous structure. So for further analysis, combined meshing was used. The table also shows that using tetragonal elements results in increase in second and fifth natural frequency than the natural frequency of the uncracked beam. But all five modes decrease when partition is used. So it can be said that the partition would provide better accuracy in result. So it can be seen from the table that The change in natural frequency is negligible unless the crack opening is significant. In this study, for further analysis, crack opening size of 0.010 meter is considered. The graphs illustrate that the change in natural frequency for different crack position is not similar for all modes of vibration. For example, the natural frequency for first three modes of the vibration, here you can see in the slide, rises with the movement of crack location away from the fixed end. But for the fourth and fifth mode of vibration, the frequency decreases as the crack moves toward the middle section of the beam, then increases as it moves towards the end of the beam. The graph in the table shows that the resonance frequency for 1 kilonewton vertical load increases as the crack location moves away from the fixed end, which is similar to the first three modes of natural frequency. There is a certain decrease in displacement near the 90 to 100 range of frequency. The 5% structural damping is responsible for that. Well, here you can see the resonance analysis, like I said. Uh, well, in fact, the frequency in which displacement is zero is the real resonance frequency for this vertical load, as 5% structural damping has been applied. Hence, resonance has shifted and the maximum displacement has also been reduced. Without damping, the displacement will be very high, resulting in the collapse of the structure. Uh, from the mode shape analysis, it can be said that the resonance frequency for the applied load is associated with the third and fourth mode of vibration of the beam, and it can also be said that the resonance occurs earlier if the crack is located closer to the fixed end of the cantilever beam. It tends to be seen from the diagram that the reverberation happens prior when the crack depth is bigger. Likewise, it can be seen from the diagram that for crack depth of 0.075 meter displacement is sensibly higher than others. This is due to the fact that a crack of 0.075 meter reaches to the web section of the beam. So here comes the conclusion and future development part. So in our project, we can conclude with such a note that for a certain location of crack, the natural frequency reduces as the crack depth increases. While designing cracked structure mesh refinement should be considered for the more accurate result. Effect of crack is different for different modes of vibration. For I-beam, natural frequency reduces significantly if the crack reaches the wake section of the beam. Resonance occurs at earlier imposed frequency if the crack is located closer to the fixed end. Resonance occurs at lower imposed frequency if the crack depth increases. The effect of vibration will be significantly higher if the crack reaches the web section of the I-beam. So this study can be extended in the by changing the damping percentage, or by changing types of load, or by changing types of the beam. So thank you for your presence. That's all.